I can see that there's an old back metal box which is all rusted away.
Is this a tape or is this a crimper? Maybe it is crimped, but it's gone really, really bad. You're not supposed to be crimping solid copper cables. Now you see the extent of everything. I just pulled that brick off wood that someone glued in using no nail.
Emergency. We always reserve time for the most in need. And then we just go into this customer. I've seen the picture. I'm like, oh my God, it's not only one thing that's gone wrong. If you can spot the 10 things that gone wrong, then you're good. I'm on my way to get there. But dear me, trust me, it's just one of these things. We always reserve some times for emergencies. I'm willing to go after hours and help these people because I'm aware how bad and how cowboy the work has been put in there. The power is not coming on, whatever the deal is. If I can record on site, it will be a brilliant video. So let's see if I can record it. If not, I'll give you my opinion and I'll take some pictures along the way. See you on site. Okay, this is a good news. Customer did allow us to record. I've already been here just asking for a permission. Have a look at it. There's a few things here that's already gone wrong. So I can see that there's an old back metal box which is all rusted away. Told the client that this most likely has been an original. We are in the extension of the property, so this was insulated. Not the best way of insulating because the electrical system has never been actually brought into the standards that it should be. And there is a fix on that red cable, as you can see, and I don't know if it's the fix that gone wrong. It looks like it's overheated, so we're gonna find out if this is even a ring, if this is actually running under the strain of overloading the installation, because it's all melted. This is the link to the back box which actually snapped. The cables were loose, they just popped out. Is it the case of loose termination? But if it was loose, it would be heating at this end, not at the point of the connection. So firstly, what I'm going to do is, when I got... there it is. So this is what happens to a copper when it's been overheated. So the physical aspects of this, it's just gone. It's no longer soft metal that you can bend. So what's that? I think that's just tape. Yeah, so they've put the tape on that and they've put a proper crimp here. Interesting. First things first, let's get in and open this up. So we got stranded earth. I can still see a grey insulation here at the back. The copper is a bit green as you can see. So let's find out if this is even still within the ring. I'm gonna clean this off and do end-to-end continuity, and then I'm gonna go, just carry on testing just to see what we are dealing with. So customer told me they moved into the property not long ago and realized there might be something off with the electrical. There was work happened to a property, I can tell. Like kitchen would have been remodeled, but it wouldn't been done by an electrician because they put the hob right in front of the switches. So that just indicates that someone was here on cheaply to get this done. Never mind, we are here to find out how safe this is and what can we do for our customer. So first things first is continuity on this installation. Great, okay. What do we get? If we we'll start with earth to earth. Nothing. So that means it's not a ring anymore. So I wonder if this is even a different problem. So neutrals. Still nothing. And let's try live. Still nothing. Okay, so this is not a ring. Let's check insulation resistance. As there might be other stuff plugged in, I'm gonna test this one first. We're gonna go insulation resistance at 250, as other stuff might still be plugged in. And what the reading is 2.6, okay. 2 mega ohms is the one that is like minimal passable. I would be shocked if I get anything better here because of the rust insulation present damp that the previous owner or whoever decided to redo the kitchen at some point was dealing with at the time. Okay, so that one is just over 2 mega ohms. Let's check this one. Actually, what we're gonna do is we use these clips. That one on the live, that one on the neutral. So live and neutral together to earth.
This one, let's see what readings we're gonna get on that. Yeah, same again. Right, I'm gonna go and put the power back on. I imagine one of them will be live, one of them will be dead. And then I imagine that some of the sockets in the kitchen would work, some of them would not. Customer already told me the kitchen is separate, which is a good thing, so it wouldn't affect the rest of the house. Please take notice, customer has already isolated the circuits, which is a right thing to do. Okay, we got only 2 circuits on. So what we have, a new meter, tails 25. I can see that the incoming supply is TNCS for the earthing. I imagine this is a gas bonding. Yeah, the gas is going there, which is good. Okay, so right there, some cables are being fixed, extended. So these are the ones. This is extended, so that means the fuse board had been changed at some point. So we're gonna leave that circuit alone, that's fine. Let's move on. There's nothing on these two. That's lights which are currently working. This will be the cooker in the kitchen, so we can assume that this is just on its own. And now we have these two 16s. That would maybe explain why there wasn't a ring, because it's non-existent. So that's one side. Let me go and check if one of our cable is live or not. Nothing's happening. Let's check the other side. Right, turn this one off. Flick this one. Silent. I didn't hear anything going on, okay?
A few moments later.
Okay, we have something. Okay, sorry, now you can see. So that one is off, that one's on. Let's check if we actually get the good voltage here. Can we get ZS at all? If we do a ZS test, that ultimately will test polarity, voltage, everything. Okay, to do a ZS test, we grab blue one on the neutral, the green on the earth, and the red one onto the live. Earth loop impedance, yes. And we can see 230, so PE to L, that's protective earth to L, that's correct. Live to neutral 245, slightly larger, and neutral to earth is 1 volt. Well, we shouldn't have anything here, so let's just run this test. Okay, as you see, it's not even passing the test. This is TNCS earthing arrangement, and I'm reading 55 ohms for the earth loop impedance. That is very not okay. I wonder, indication of all the rust and all the moisture and damp within the walls might have degraded the cables even more. This is a bad reading. My socket isn't working on the other side. I wonder what's gonna happen if I just clean the copper, clean those cables, join them together and see if the other side is coming on at all. But we also have that other circuit which is tripping, so that's also interesting points. So what we're gonna do is, here I will put one of my R1, R2 test leads, which is this one, live with earth, like this. Plug it in, I know. I get my simple continuity tester. We'll see if this second cable, which is currently not live, it has anything to do with that. So we're looking for the sound. Up. Okay, so this cable actually does go over there. So yeah, I will continue to do what I just said. Clean the ends terminal, I will join them together and see if we can revive the sockets on the other side, which will do the washing machine, the dishwasher, oven. It's a few appliances. So the washing machine, about 2.7 kilowatts. Dishwasher, about 2.2 kilowatts. Definitely 4.5 kilowatts. Just these two alone in this heating cycle, both of them would be more than what a circuit breaker will allow it. The cable is being protected by 16 amp fuse. Overloading the installation, well, the circuit breaker should trip. So overloading could be an issue here, but obviously 16 amp circuit breaker would protect the cable, which can withstand easily 25 amps, depending how it's installed and depending how good. Well, in this case, not very good.
One eternity later.
And let's put this back on. We do have power to these sockets. Let's check if the oven is on. Oven is not on. Okay, let's check the appliances. 1, 2. Yes. And Is it on or is it me? Oh, it is on, yes. So both appliances are on. We just don't have any safe way to put the socket in here because there's not much that we can actually put the box into, and this requires further investigation just to see what is happening on the 16 amp. I know the oven isn't working at the moment. I wonder if there's a problem with the fuse. Shall we check? How do you test the fuse? If you don't have less expensive stuff, you just pick up your phone, for example, you put your finger on, yeah, and if it does click, the fuse is all right. So it's not the fuse that is gone. This should be on because that's the cooker circuit. Yeah. For whatever reason, the hob is working, but the oven is as well. Okay, so they're both on the same switch. Cool, that's fine. So that would be for the extractor fan then. Maybe I'm not seeing it. Oh, yes. No, it's not. For whatever thing that is. I don't know. The emergency appointment is to establish what is happening and how we can help. There is RCD which we going to test. If the RCD is working and we immediately attend to the burning cables, we can see that the previous attempts at fixing it, I believe it just gone wrong because it was a tape. Here it is. Is this a tape or is this a crimper? Maybe it is crimped, but it's gone really, really bad. You're not supposed to be crimping solid copper cables because they are just not meant to be, you know, crimped. Okay, RCD testing. This side, AC 30 milliamps auto test. Okay, it will trip 8 times. Hopefully it will trip 8 times. That's the idea. That's 1. That's 2, 3, 4, 5, 6. Oh, sorry, 6 times. Yeah, because it's 1, 5, and then the ramp test. It's 8 tests, but 2 of them shouldn't trip. Times 1, 27.3 milliseconds, 180 is 19 milliseconds, then at 5 is 8 and 16. Ramp test 24 milliamps and 22.5 milliamps. So RCD is healthy, it trips within the specified time. The cables are protected here at my client's house, but one of those circuits is tripping at me. The question is, how can I close this up and make it safer? I see someone had an idea of putting this in, and kind of they succeeded it. It's bad, I know. Maybe we will return a similar thing. Just to put this empty, unconnected socket in front of it, we would need to cover it with something, but how can you cover with something if we don't have any something? What? People, this is not the way you should secure your sockets, but this is just to cover the cables, really. We just make them, you can get in contact with the live parts, which that's the idea. Now you see the extent of everything. I just pulled that brick of wood that someone glued in using no nail, because I know that's how it looks like when it dries out. I can't put anything right here in front of it that would be remotely safe-ish. Let's see what I have in the van. Okay, as we have a very limited options to what we actually are able to put on this faceplate. There's no backing, no surface available. I've got this big white electrical tape. That's the only thing I can think of to put it in. It's a temporary fix. I'll tell the client that this is something that needs to be looked at. Wiring for the kitchen would need to be considered, as if this is the case, throughout the kitchen, that's definitely not the safest. With the reading of just above the 2 mega ohms, we are getting close to the end life of this installation. I physically cannot put any barriers, and I don't want to put anything semi-permanent because it's not meant to be. This is meant to be actioned as quickly as possible. Could leave it just without covering, but not feeling very comfortable just leaving it not covered. There are kittens around the house, and while kittens might be exploring this side of the kitchen, jumping on a table, I'm thinking like, yeah, if we just cover it up, I don't think they are gonna be breaking this tape to gain access to this socket. Well, that's all I can do right now. Tell the client that this is definitely something that needs a look at. Okay, I'll see you in the van.